So up until now, the only thing we've talked about with experimental design or experiments is observational study versus experiments. So now we're switching gears and doing everything with experiments. The main thing that we know right now is when is it an experiment versus observation study if we what? Impose a treatment, and which means we can do what? What can you do if it's an experiment, not an observational study? Causation. So that's all we know right now. Now I have like the words written off to the side on this paper, but you're probably gonna want notebook paper to go with it because some of the stuff I tell you right is really bigger than the space you have. So a lot of the definitions you're actually gonna run on with notebook paper, but I still want you to have this. Now I don't think it's necessary to rewrite the definition of observation study experiment because not only have we already talked about it, but I also just put you on it, so surely you know what it is by now. Observation study, we observe without imposing. Experiment, we actively impose some treatment in order to observe responses. So we've already talked about that. Hopefully I'm going to be loud enough much here. So at this point, I'm going to kind of talk through a theoretical, strange example. So let's say theoretically that I have developed this new rabbit food called Hippity Hop. And I say things like, it makes their fur soft and shiny, it increases their energy, 100% of daily vitamins and essential oils. Can I just make these claims? Like I said, this is my new rabbit food, it does this. Can I just say that?
Yeah, you
Can I just say that and be right?
No.
So what do I actually have to do to say those things? So based off of the conversation we just had, in order to say that it actually does increase energy, I have to do what? An experiment. If I have to see if it actually makes the hair soft and shiny, I have to do an experiment. So can I just make the claims? No. What must I do to make them an experiment? What or who should I test my experiment on in this scenario?
Whatever it's going to be.
So in this scenario, it would be what?
The rabbit.
And then what am I testing?
If it does what you say it does.
So I'm going to be testing the food, and that was kind of a weird question. I'm testing specific things. I would actually do different experiments for each one of those. I don't like the way that one's asked. Alright, so this next vocab, I don't love the definition that's up there. I'm going to word it a little bit different. So experimental unit, this is the smallest unit to which the different treatments are applied. So it is the smallest unit to which treatments are applied. And I'll explain that. So smallest unit to which treatments are applied. The majority of the time, an experimental unit is going to be super easy and you know exactly what it is. So what is my experimental unit in this scenario? The rabbits. That's the smallest unit to which I apply. It can get a little bit funny though. If I do something like PSAT testing at schools, what are my experimental units?
Us.
The students. When they rolled out Chromebooks, they did it school by school. Who's getting the Chromebooks? The students. But what is the smallest unit to which the treatment of getting a Chromebook is applied? So in that case, the experimental units would be schools, because I'm choosing, like I think Malden and Riverside maybe were the first two to get them. Malden and somebody were the first two to get them. And then the next year, two more got them and so forth. So it's the smallest unit to which the entire treatment was applied. So it can get a little funny with what it actually is being like schools versus individuals at that point. Most time it's just as straightforward as you think it is. So when you usually think of something we measure, so like a variable on a graph, you have x and a y. What do you used to call your x variable? What do you call your y variable?
Your dependent variable.
Oh, what's nothing other than independent and dependent? Those are right. But explanatory and response. So does your sheet say explanatory variable at all? I don't love that. Oh.
You can write it on.
Yeah, I'm trying to think about what I want to do it. No, I don't do it. Okay, so factor is your explanatory variable. I like to think of factor and level as explanatory variable. Factor is your generic, and level is your specifics.
What is explanatory variable? Okay.
So, in this example with the rabbit food is my factor. That's the treatment that I'm imposing. We haven't gotten into the specifics of this one, but level might be how much rabbit food I give them. So it's a specific value of that factor. Now that's kind of a weird scenario with finding a level to go with the factor. A better example would be something like sunlight exposure. Some plants get full sun, some plants get no sun, some plants get half sun. So like sun would be the generic factor, full, none, and half would be your levels of that factor. So it's just like the breakdown. And then response variable is what you measure. It's kind of the whole thing that we're trying to figure out about the whole experiment. So treatment, write this down and then I'll explain it. So treatment is a specific experimental condition applied to the units. It's a specific experimental condition applied to the units. So it doesn't really make sense unless I give you an example. Let's say something like you're doing exercise. Like I'm trying some workout plan with different people. They either do exercise or they don't. And then their diet is either, we'll say diet plan A, B, or C to make it easy. So in this plan, both of these are considered a factor. Yes and no are the levels of exercise. A, B, and C are the levels of diet. So what is the first plan someone could be on? Yes, A. So that would be the entire treatment is when you put them together. But it doesn't make sense if I'm talking about it without multiple factors. So like here, there would be 6 treatments. Yes, A, yes, B, yes, C, no A, no B, no C. But if it's something straightforward like I'm giving them the new food, I'm not giving them the new food, then it's really straightforward and your treatments are the exact same thing as your factors. Alright, so I plan to test my new rabbit food. We just talked about this part. What are my experimental units?
The rabbits.
The rabbits. I'm I'm not giving much information, so this is kind of a terrible way to go through it, but it just kind of helps. So what at this point do you think is my factor?
I don't quite get the factor.
So I'm just testing my rabbit food. So type of rabbit food is whatever the factor is. Like I'd probably do like my rabbit food and no rabbit food or different rabbit food, old rabbit food, something like that. So again, what is my response variable? I don't think that one was.
It was like they're in shiny.
So basically how well it works. I mean, I was not very specific in this example. Okay, so at this point, this is my rabbit. The name is rabbit. So I decide I'll use my pet rabbit and give my rabbit food my new rabbit, or give my rabbit my new rabbit food. And then I decide my rabbit's coat is shinier, he has more energy, so Hippity Hop is a better rabbit food. Everybody get that point. So I made this new rabbit food, I tried it on my rabbit, I made those claims. Does that seem like a good thing?
Sure.
What are issues? Nothing to compare it to. So our first issue is I have nothing to compare it to. It could have been the fact that all of a sudden it's nice outside and my rabbit likes that a lot better. So I have no idea if the changes were because of the rabbit food. So the first thing we need is a control group. The whole point of a control group is to be able to compare it to. A lot of times in studies with drugs, a placebo is used, so they look at it and they think they're getting the pill, but they're not, or they don't know if they are or they're not. In my scenario with the rabbits, I could have done it like the old food versus the new food. The old food could be considered my control group. So what is a placebo?
The original thing, or whatever.
It's like the treatment that only works based on expectations.
So what's the, and you're answering beyond, you're answering it right. Like if I explain to someone, I'm giving you this and it's a placebo, what am I actually giving them? Nothing. So it's like a fake treatment essentially. It's a fake treatment, so it shouldn't have any physical effects, but it actually deals with the psychological aspect of it, which we'll talk about in a little bit. Now, a placebo is not something that can always be used. If my only factor is exercise, no exercise, can I give somebody a placebo?
Mm-hmm.
They can't like think they're working out, but they're not. So it only works in some scenarios, obviously. So now I go and take my friend's rabbit. So I've got my rabbit, my friend's rabbit. I give my rabbit the new food. I give the other rabbit the old food, and now I compare them. Well, mine is bigger and shinier, so my rabbit food works. So I've implemented the compare, the control group. What are issues now?
The rabbits start out the same.
The rabbits didn't start out the same. Now, am I usually gonna get things that are the exact same? No, but so what can I do instead?
Get as close as you can.
So first of all, get as close as I can, and if I get two rabbits and one of them does well and one of them doesn't, is that great?
You just probably need more rabbits.
So maybe I can just get more rabbits. So now I go out there and get more rabbits, and I've got to decide who gets which. So the first 5 rabbits that I catch are going to get the new food, and the remaining 5 will get the old food. So I go through this process. First 5 that I catch go here. The rest of them go over here. At the end, the ones that I gave the Hippity Hop rabbit food to end up scoring higher, so it's better. Am I good at that point? So what was bad with what I did?
You took all the big rabbits first.
So there was something about the way that I picked them. If I picked all of the first ones,
Well, catching them is probably easier. It's easier to catch a bigger rabbit.
right, or even I'm gonna catch the slower rabbits maybe. Slower rabbit, but they're gonna all be similar for some reason. So this goes into the sampling aspect. You want to take yourself out of the process of selecting the samples. So what would have been a better way to do this? One word, I definitely need to pick which group they're in randomly. And I could actually sit there and give all the rabbits, I could line them up in some order if I wanted to, but somehow give them each a number, give them each a name, I don't care. And then go through the randomization process like a random number table or anything that we've done, or place them in a hat. First 5 numbers pulled from the hat will get hippity hop food, the rest of them get the old rabbit food. Do you see any issues with that? No, because I mixed them up, I've taken the first 5, I can sit there and draw out the next 5, but I don't need to. So at this point, I evaluated the rabbits and found that eating healthy or eating my rabbit food makes them better. What is the issue there? It is that I did it. So why is that an issue?
You have personal bias.
I have personal bias. It's my rabbit food. I'm gonna be looking for things that make it look like my rabbit food was better. So I have personal bias in there. So I want to take myself out of this. So what's the next word we're coming to? Blinding. So that doesn't mean you really go like make somebody blind. But it's the idea that you don't know which is which. So this happens a lot in actual research. It's beyond the extent of our class, but essentially if I were doing a study like this, I would go bring my research to some group of people and just hand it to them and say, I'm testing these rabbit foods against each other to see which one's better, and give it to them, and they have no idea which group is which. And all they do is do the research, do the numbers, give it back to you, and they never know which one was better. Like they'd say this one that you called A is better for all these reasons, but they would never know which was which. So double blinding means the evaluator and the subject didn't know which one they were getting. Now the evaluator can be the sense where like they're actually recording the data or they're running the numbers, so it's like on that end of it. Now, would I need to blind the rabbits here? Does it really matter that I tell them which rabbit food they're eating? If it does matter, then you should probably take your rabbit somewhere because it's really special. So if it were the exercise thing, they're not going to be able to not know that they're exercising or not. But something like a new drug, if I have a placebo and a regular drug and they look the exact same, then the person doing the subject has no idea which treatment they're getting. And then I give the data to the evaluator and don't tell them which is which, and they don't know which is which either. So that's when it's double blinding. So double blinding is definitely preferred, but obviously there are scenarios where it can't happen. Just like I can't blind you to whether you're working out or not. One thing I was thinking about, what I want to go back to though, where you wrote experimental units. If they are people, we call them subjects. So experimental units, just put like an arrow or something and say subjects of people. So in my rabbit example, I wouldn't call them subjects, but if I were talking about people, I could use the word more specifically in subjects. Just because here they talk about the subject.
Where are you writing
Experimental unit. It was like the first thing we wrote down in
that?
answers.
Subjects equal people.
So now I'm getting to the point that hippy hop rabbit food makes fur soft and shiny and increases energy for all types of rabbits. really talked about my study very much, so I don't know if I can make that claim or not. There are benefits and downfalls to this first aspect. If I were just testing a new rabbit food, I would want to probably make sure that it really worked. So I want to control as many outside factors as possible. So I might do all rabbits of the same breed. But eventually I would want it to work for all rabbits. So I would want to consider that too. So this first thing, control. Control comes in two aspects. There's two aspects of control. We talked about one, which is a control group. And we want a control group because we want it to compare to. We also want to control as many things as we can to make everything the exact same except the one thing we're changing. So if we're doing, if I'm just testing a new diet, I would want to control how much they get to exercise. I would want to control how much sleep they got, stuff like that. If I had a new plant and I'm trying this new soil, I would want them to have the same exposure to sunlight, the same watering process, the same everything. So control, the two aspects are effects of extraneous variables, which are all those little things that you can deal with, the sunlight, the watering, all that stuff. And then also the fact of a control group is a baseline to compare to. So these are the three principles of experimental design, and they are extremely important. Did I skip something somewhere when I went through? Confounding. Okay, I knew I skipped something. Come back to it later. Was it the last one on the list?
Yes, ma'am.
Okay. Alright, so control. We want to take away all the outside factors as much as we can. You can't ever deal with all of them. And also compare group. When we started initially, before I did a control, or after I did a control group in the scenario we just went through, so we said I just tried it out on my rabbit. You told me I needed control, so I got my rabbit, my friend's rabbit. At that point, you told me I needed what? You needed more of them. So replication. And you guys were actually talking about the justification behind replication when you were telling me to do this. You wanted them to be this, you said they weren't the same, and you wanted them to be the same. Now, in life, are things always all going to be the exact same? No. So if you repeat it on enough individuals, you're expecting a little bit of variation, but that little bit of variation will kind of not stand out as much. So like if I'm grabbing people with height, I'm going to get a couple short people, but it's still kind of going to balance out, as opposed to if I only took 3 people and I got one who was really short, that would really throw things off. Alright, so then I switched, and so it's to quantify the natural variation. So you're going to have chance variation, and you're trying to account for that chance variation, or the only variation is chance variation. Alright, so then I had my 10 rabbits, and I said I got the first 10 that I got, and y'all told me that was bad. Y'all told me I needed to do what at that point? How did I need to select them? So you want to take yourself out of the chance, or out of the selection process. You want to leave the selection process up to chance. So 3 principles of experimental design: replication, randomization, and control. And so the other day I said causation can only be implied with an experiment, but I said, well, technically a well-designed experiment, don't know what that is yet. This is what I meant by that. So the only way to show cause and effect with well designed, well controlled experiment, that's what I've talked about. We've talked about that a lot. It's still the same thing as before. We just have a more specific definition of what it means to be an experiment. Alright, so you got a couple examples on yours. This one's written on yours, correct?
Yes.
Okay. A farm product manufacturer wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizers. So we take 15 similar plots of land and we plant them with the same type of seed, but they're fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. What are our experimental units? The plots blank, because, okay, so I sometimes go backwards here. What is our factor? The fertilizer. How many levels of the fertilizer do we have? 3. To what are we applying the fertilizer? The plot of land. So we just said types of fertilizer, and it just says there are 3 types. It wrote A, B, and C. You could write type 1, type 2, type 3, I don't care. You're just understanding there are 3 types. So what is the response variable we're measuring? And crop yield, it was very vague in the wording. It said mean yield of crop, which is probably a more appropriate answer to write. I'm afraid to move this over. I'll forget to stop recording. All right, and how many treatments are there? 3, because I only have 1 factor with 3 levels, so we only have 3 treatments. Now that one makes sense. Now most of you are like, okay, this is boring, I don't care about plots plan. I get that. This one at least I think is the most relevant to start out with. So we're trying to say that again.
You get back to that.
I also wanted to say what is the point of similar plots of land that are planted with the same type of seed but are fertilized differently? So what's these 2 lines right here, what's the important part of that? The control. So I'm controlling by doing similar plots of land and the same type of seed. I'm controlling there. So here a consumer group wants to test cake pans to see which works the best. It tests aluminum, glass, and plastic pans in both gas and electric ovens. I like to think about this one out of order. What is our response variable? So the evenness of the bake. So what are our experimental units? What are we testing to see the evenness of the bake? The cake batter. And that's why that one's kind of weird at first. If you started this problem and started writing it through and you didn't answer experimental units correct, you would probably catch your mistake at some point. Yeah. There you go. What are our factors? Pan material and oven type. And you don't have to write 2 factors, you can just write oven type, pan type, that's fine. So when I usually do this, even though it says what are the factors, what are the levels, even in a problem like this, I would write it as and then what are my levels of pan type? And then what are my levels of oven type? Any way other than writing like that, I think you're either writing too much or it's kind of pointless. So it writes it out funny and like essentially rewrites factors and levels, but I like it written like that because it's straightforward and it's less writing. So like they wrote, the type of pan has 3 levels. Well, I think that's just pointless writing. So we said our response variable is the evenness of the cake. And then so in this one, how many treatments do I have? How can I always figure out how many treatments I'm going to have? Multiply the number of levels. So even if I have like 4 levels and I have these crazy number of factors for each one, just multiply the number of levels for each one to figure out how many total treatments there are. And then farm product manufacturer wants to determine, so this goes back to the same one we just talked about. Why is the same type of seed used on all 15 plots? Part of the control. The extraneous variables, I'll call lurking variables a lot. There's some stuff that I'm going to add to this later. So what are some other potential extraneous variables? So extraneous variables are other things that we did not control for that may directly impact our response variable. So our response variable here was the yield of crop. So what are things?
All right, we have your results for the second block, class challenges. Miss Hyder and Miss Faust, it was super close. Miss Hyder with $109.11, but Miss Faust came up on top with $115.61.
The amount of water.
Keller versus
Like if
Miss
it's on a
Sullivan.
slant
Keller got
versus flat, that'll make a big difference with
$30.37
drainage and stuff like that.
and Sullivan with $53.
Does this have a placebo?
Nessberg with $6.35,
you're not trying to
but Mr.
trick the
Bell
soil,
won
that's
that one
what
with
you're
$15. Great job, guys.